This timeline compares the 2 million-year history of Homo erectus against the roughly 300,000 years our own species has walked the Earth. They are the longest-lived human species in history, surviving for nearly 7 times as long as we have so far. During that immense stretch of time, they achieved a series of biological firsts. They were the first hominins to exhibit modern body proportions, the first with the physical capacity for long-distance running, and the first to successfully leave Africa to spread across the globe. But the species that pioneered global human life eventually hit a wall. The last known trace of them was recovered from the island of Java, dating to a final holdout between 108,000 and 117,000 years ago. Their disappearance was a slow, agonizing process. The archaeological record suggests a cascading failure driven by 5 distinct, compounding environmental and biological pressures. The mystery lies in how such successful pioneers could be undone by the very environment they once mastered. The first pressure arrived in the form of violent shifts in global temperature. For hundreds of thousands of years, Homo erectus thrived in open woodlands and grasslands, environments that rewarded their ability to run and hunt large game. As the climate warmed and grew wetter, those familiar open plains began to vanish. In their final refuge in Java, the landscape was completely replaced by a dense, humid tropical rainforest, an ecosystem where they possessed no physical adaptations. This environmental shift triggered the second pressure, severe resource scarcity. As the forests thickened, the massive prey animals that Homo erectus relied on, particularly elephants, began to disappear from the region. This table details hominin diets. At Gesher Benot Yaakov, elephants were the primary dietary anchor, contributing 61% of calories. But in later Kesem cave findings, elephants are completely gone. Without megafauna, Homo erectus expended significantly more energy hunting smaller, faster prey. This metabolic trap made survival a losing game of math. The loss of high-fat prey turned daily life into a state of permanent caloric deficit. As their populations weakened from starvation, a third pressure emerged: fierce interspecies competition. Highly adaptable, generalist human species were moving into their territories. These newer hominins brought advanced technology. By utilizing complex stone tools and flexible hunting behaviors, they exploited resources far more efficiently than Homo erectus could. The resulting starvation and competition triggered the fourth pressure, a demographic collapse. A population that spanned 2 continents fractured into tiny, fragile groups, trapped on isolated islands. This isolation was lethal. It stripped away genetic diversity and destroyed the wide-spanning social networks that modern humans would later use to survive localized famines. We see the cost of this vulnerability in the descendants of erectus on Flores. Their isolated populations were pushed to the edge of survival before being decimated by localized disasters, including a massive volcanic eruption that violently blanketed the island in thick ash. Without a social or genetic safety net, survival became impossible. Events that a larger, more connected population could have endured instead became definitive extinction events. For the remnants of the species that avoided starvation, the end came through a fifth and final pressure: genetic absorption. This diagram shows the branching of the human lineage. Genetic evidence reveals that roughly 700,000 years ago, ancestors of Neanderthals and Denisovans interbred with a super-archaic human population that had left Africa long before. Over countless generations, the distinct traits of Homo erectus were gradually diluted. They were bred into the lineages of their more dominant neighbors. This genetic merger effectively ended the species as a distinct biological group. Their unique identity was absorbed into the ancestors of the people living today. Today, all that remains of Homo erectus are fossilized fragments and ghostly traces of DNA. They have been pruned from the human family tree. The very pressures that destroyed them, the shifts in climate and the disappearance of megafauna, acted as the crucible for our own evolution. These challenges forced our direct ancestors to develop lighter bodies, larger brains, and more flexible social strategies. Paleoclimatologists now view this collapse as a warning. If even the brain powerhouse of the animal kingdom could be wiped out by extreme climate shifts, modern humans remain equally vulnerable to the environmental changes we are causing today. Long-term survival relies on more than just biological strength. It depends on our ability to cooperate and maintain the fragile ecological balance of the planet we inhabit. The collapse started with the climate. Around 400,000 years ago, global temperatures fluctuated wildly. In places like Java, the open, grassy woodlands they relied on were swallowed up by dense, unfamiliar tropical rainforests. This environmental shift exposed a fatal biological vulnerability. Homo erectus had evolved large, energy-hungry brains and heavy, muscular bodies. To sustain that anatomy, they required massive, continuous amounts of dietary fat. This paper, Man the Fat Hunter, outlines their biological need. Survival depended on hunting enormous, fat-rich megafauna, particularly elephants. But as climate transformed the landscape, these herbivores died out, and the primary pipeline of calories sustaining Homo erectus vanished. To survive, they had to hunt smaller, much faster animals. But their heavy, robust bodies simply weren't built to efficiently chase down nimble prey across rough, dense terrain. The shifting climate shattered their food web, trapping the species in a biological energy crisis they could no longer solve through hunting. Starving populations abandoned vast territories. Their once connected network fractured into isolated pockets clinging to shrinking resources. Cut off, these tiny groups lost genetic diversity, becoming highly vulnerable to shocks. Finally, new hominin species migrated directly into these exact same territories. These newcomers brought fierce, direct competition for the last remaining resources. And, as genetic evidence shows, they also assimilated the stragglers through interbreeding with groups like the Denisovans. Isolated, starved, and out-hunted, the distinct Homo erectus lineage was slowly squeezed out and genetically absorbed until the species completely ceased to exist. This raises an obvious question. If this climatic period was brutal enough to wipe out a globally established apex predator, how did early Homo sapiens manage to survive the exact same conditions? The answer comes down to strategy. Instead of waiting hundreds of thousands of years for their biology to physically evolve to fit a new environment, Homo sapiens adapted their technology. They engineered complex projectile technology, like spear throwers and bows. This allowed a hunter to safely and efficiently strike the small, fast game that Homo erectus couldn't physically catch. They crafted delicate bone needles to sew insulated, weatherproof clothing, allowing them to survive extreme drops in temperature without needing to grow thicker skin or fur. And they innovated socially. They built extensive kin-based networks across massive landscapes, which allowed neighboring groups to share resources and knowledge whenever a local territory failed. Externalizing adaptations into tools and culture allowed Homo sapiens to decouple their survival from their immediate biological traits. The fall of our most successful ancestor carries a clear warning. Raw biological resilience is fragile. As humanity faces modern, human-made climate extremes today, our ultimate survival will not depend on our physical strength, but on our capacity for rapid technological innovation and global cooperation.